Okay, good day, everyone. No, another lecture from me for our course or subject na structural theory or CE 311. Ang pag-uusapan natin ngayon is about supports and connections, no, for plain structures lang. So later, if we have time to go to space structures or 3D structures, I can discuss it, no. But at the meantime, no, let's review, no? Review na lang naman itong supports and connections, no? Kasi naturo naman ito sa inyo noon sa um, strength of materials or sa rigid bodies, no? Sa mechanics, no? Tinuro naman to sa inyo sa mechanics, no? So anyway, let's proceed, no? So in plane structures, no, meron tayong dalawang translational directions, no? We can call it the horizontal direction or the vertical direction, x and y, or kahit ano, no. Hindi naman talaga ano yan, sigurado na uh, or always na horizontal or vertical talaga yung mga translational. So itong tinatawag na translational, no, yung x or yung y, then meron tayong iisang rotation. Yan yung makikita natin sa plane structures lang. Sa rotation naman, it can be counterclockwise or it can be clockwise. As you can see dito, nakikita nyo it is clockwise, no? Mm. So in 3D or space structures, no, as you can see here, pwede anim lahat na nakikita natin as maximum restraint, no. So pag-uusapan kasi natin dito is ang support at saka connection, which means there is a restraint, no. Kung sa support ka, there is a restraint, no. No. So sa plane structures, tatlo ang ating maximum restraint na isang rotation, dalawang translation. And on 3D naman, no, if ever makaabot tayo dito, we can have maximum support, no, maximum restraint, no. We can have the XYZ translations, no, 3. Then we can have the rotation at X, rotation at Y, rotation at Z. No? So 3 plus 3, so 6 lahat, no? Ang pwede nating restraint. So meaning ng restraint, uh, yun yung from the word restraint, no, yun yung pipigilan niya, no. If we have a support, no, that can restrain this lahat, meaning yung reaction naman doon lahat rin hahanapin nyo. For example, we have three restraints sa plane structures, no, dalawang translation, dalawang rotation. So ang unknowns doon tatlo rin, no. If isa lang, then isa lang. So yun ang meaning na restraint. So it is the reaction, no? Yung reaction, yung R na hinahanap natin, no? Let's proceed. So by the way, we have three categories, no? Ng ano, no? We have category 1, category 2, category 3, no? So let's proceed, no, sa no ating category. So first is the category 1. So sa category 1, no, ang support lang naman nito is ang restraint niya is a single translation lang, no? Single translational direction lang. Oh. It's either in the horizontal, vertical, or kahit inclined pa yan. Basta, ang kanyang restraint is a single translational direction lang. So we have, I think, three examples dito. As you can see, our very first example is the roller or ball support, no? So ito yung ano niya, definition niya. Reaction R, no? Lagi yan siya, no? If it is a roller or ball support, it is always perpendicular to the supporting surface. Like for example here, no? Dito nakita nyo dito, no? The supporting surface is inclined at theta. So therefore, uh, the R dito, yung dito niya, no, R is inclined also at theta, no? Yun, no. Since they must be perpendicular. So dito ang supporting surface dito is nasa 0 degrees. So yung R natin is naka 90 degrees, no. So anyway, pansin nyo naman dito, makikita nyo ito sa mga bridges, no? Makita ito. So this is a typical roller supported connection. So we have a concrete here, we have concrete, tapos meron tayo ditong ano, patungan niya, no? Roller, no? So ito example ito sa bridge, no. What is the purpose of this? That is for the no vibration, no, or ano, Vibration kasi siyempre madaming dumadaan dito, may vibration yan, hindi pwede na i-fix natin kasi kung i-fix natin dito or ipin natin yung both sides, there is so much wala na masyadong leeway para sa movement ng bridge, no? Mas maganda pa rin na meron pa rin isang part ng bridge na gagalaw, no? Hindi naman sinabi na both talaga sides ng bridge is rollers, so ibig sabihin yung tatakbo ng bridge nyo, yung isang part nakapin, tapos yung isang part is naka-roller. So ito roller. So nilagay ito. So sometimes we can see also a ball, no? And as you can see here, no? Meron tayong typical dito, although nakapin siya, which is which is itong rigid body nakapin dito, but the main support of this one is the roller. So isa pa rin yung kanyang reaction, no? That's one example, no? I know that naalam nyo na to, but ang gi-provide ko dito is mga pictures para makita nyo sa actual kung ano yung mga makikita nyo talaga, kung anong meaning ng roller. So nakita na kayo ngayon ng roller, no? This is the actual roller supports, no? This is true, no? Kaya yung ganito na na example, totoo naman, may roller talaga. So this is the typical roller, no? All balls, all or ball support, no? Mm. So next support is the rocker support. Same with the roller. Hindi lang kasi siya bilog, no? Hindi lang rin siya ball or yung roller type, but it's the same, no? The reaction is perpendicular to the supporting surface, no? Anyway, ito yung mga actual nila nakikita. And it is still in category 1, no? Single translational direction only. So, wala naman tayo ibang pag-usapan dito. As you can see, this is the actual. You can also search it in the internet. You can see that actual rocker. Now, mostly kasi itong mga rocker or category 1 support, nakikita natin to mostly sa mga bridges, no? Because yun nga sinabi ko earlier that some bridges need to have a leeway or yung parang to accommodate the vibration na lagi kasing may dumadaan dyan, no? Nag-produce ng vibration kasi yung mga moving loads, so that kung hindi mo talaga pwede i-fix. So anyway, let's proceed, no? Another support that is belong siya sa category 1. Example is that ito, mas lalo nyo itong may encounter during your OJT days, no? Or mas may encounter nyo to talaga sa actual na construction site, no? These are the link support, no? From the word link, no? Since link siya, ikokonekta niya lang naman ang isang parte dong ng isang structure to the support, no? Kaya ililink niya. So this is still a single translational lang, no? Direction only. So, no? As you can see dito, shoring jacks, no? Itong shoring jacks or ito, ginagamit to sila. Ito, I don't know if this is a shoring jack, no? But this shoring jacks, no? Ginagamit to siya if to support the newly fresh na buhos sa slab, no? Hindi kasi pwede na walang shoring jacks during the pagbuhos sa slab, no? So ito yun siya. So ano lang yung purpose nito is that may connection ang pagbuhos, may connection sa support doon para sa temporary support, no? Para sa newly fresh na kasi ang kasi ang wet pa na slab is napakabigat, tapos after 30 days pa yan or after 14 or 21 days pa yan sila ma-achieve niya ang kanyang total strength na kaya niya ng sarili niya, no? And before that, no, bago yan siya, kailangan mo yan siya i-shore, no? So ito example sa link, no, link support. So ang gagawin nito, itong shoring jacks, gilink niya lang itong slab na bagong as a support, no, to the support mismo na slab rin dito sa first floor, no? So napansin nyo, kaya siya tinawag link support. So it's just a link between the support saka doon sa structure. So anyway, this is still a category 1, single translational, no? These are the real life examples, no? So let's proceed. Another is the category 2. Okay, no? Don't worry, this is just a review lang, no? Okay, no? Kita nyo, napakalaking structure and it is pinned. Okay. Napansin nyo, nasa Australia ito siya kasi nandito yung Sydney Opera House, no? So, smooth pin or hinge support, no? Unlike the previous category, no? Pinagkaiba ng category 2, no? Restrained siya sa lahat ng translational, no? So, hindi siya restrained sa rotation, wala siyang rotation, but it is restrained in translation sa lahat. So, review natin kanina, if it's a plain structure, no, dalawang translational lang, no. So it means this hinge support is restrained to 2, no. Kung kanina single, ito is any lahat, no, on any translational direction, no, lahat, no. Okay, I think mali yung term ko na any, dapat all ito siya, no. So wait lang, let's so all to siya, all translational direction only. So, it's all, no, all. So, ang any niya pala is in any direction, no? The reaction R may act in any direction. So, o, kung kung saan man yung support niya, for example dito, kahit saan direction siya, no? Because it is restrained in all direction, no? Sa planar. So, kahit anong direction, pwede RX, pwede RY, no? So, unlike kanina sa category 1, no, single lang siya, no, single, no. Ito, makita nyo, this is still a single pa rin ng reaction niya. But, because it can act in any direction, ang pag-compute natin dito is, gina-separate natin sila for its rectangular components, Rx and Ry, kasi yun ang pinakamadali, no. So, yung kanina, yung link naman is, perpendicular siya sa yung link kanina, no, perpendicular siya sa axis ng link, tapos yung itong rocker sa ball is perpendicular sa supporting surface. Ang hinge support naman is kahit anong direction, no. So as you can see, this yung previous ko na na YouTube video, no, na ginawa, no, yung sa classification of structures, that is video before this one, no, this is a shear connection. So ang purpose lang nito is to transfer translational direction, which is nakapin siya, which is walang rotation. So it means na walang rotation, it is not fixed, therefore walang moment na matatransfer. So ang mangyayari dito, itong column natin is magiging purely axial, lang siya, compression lang siya, wala tayong moment, although may moment talaga na maliit dito. So sa actual class, no, let's proceed na explain ko to, no. Sa actual cases talaga, mapa pin man yan, mapa roller man yan, or mapa fix man yan, there is, no, meron talagang stiffness sa torsion, or stiffness sa joint torsion, no. Meron talagang resistance yan. Resistance saan? Due to the friction and due to the material. So, pero in our case as a civil engineer, no, yun nga, as a civil engineer, no, hindi naman importante talaga na exact tayo magsagot. Ang asa atin is yung practicality. So, para mas madali ang ating analysis, i-divide lang natin lahat ang mga sa categories. Hinge, fix, roller lang, ganun lang kasimple para mas madali i-compute ang kanilang reaction. But sa totoong buhay, yun ang sinabi ko, due to the friction, due to the material, no, meron talagang dyan, no, kahit hinge pa yan, meron talagang maliit dyan na moment, no, kasi dahil sa friction, at saka as you can see, no, ito talaga yung ideal, no, torsional spring talaga yung lahat ng support. So if you have a computer aided design softwares, no, you can also model the reactions as a torsional spring, no, and kayo mag-set ng K. But anyway, if it is a hinge support, meaning wala siyang moment or wala siyang restraint sa, or wala siyang what do you call that, effects para sa moment, no, or sa rotation. So yung constant natin dyan, no, is, or K is equals to 0, meaning wala tayong torsional spring. Meaning kung walang torsional spring or walang torsional, or yung gineglect natin yung friction doon, kasi sabihin natin maliit lang yan, yung friction na yan, i-neglect natin yan, saka yung material properties, i-neglect natin yan. So mangyayari dyan, yung actual natin na structure, ito for example dito, meron talaga tong maliit na torsion, no? Pero pag design natin dito, ginawa natin siyang hinge, tinanggal natin yung torsional spring niya na ng moment na yon. So gi-make natin siya as k is equals to 0, no? If a torsional spring constants k equals to 0, meaning yan hinge. No? Meaning walang moment, no? Walang restraint sa rotation, walang restraint sa moment kasi yun nga, no? Sa actual may restraint talaga siya sa rotation. But anyway, gi-k natin equals to 0. So let's proceed to another category, no? The last category is the category 3, no? Marami kayong namang nakita dito kaya hindi na ako nag-provide na mga actual pictures, no? Halos lahat ng nakita nyo naka-fix naman halos lahat. So dito naman pinagkaiba niya, no, is that the reaction, no, same with the category 2 but may additional moment couple siya na M. So ito yung M na yon. No? So same yung Rx and Ry. So yun lang. So any translation ng direction and one rotation, which means restraint siya sa all, no? Restraint siya sa all, no? Yung kaninang previous slides, no? Restraint siya. So that is the fixed support. So as you can see, no, na-explain ko naman dun sa previous, pag may weld dyan, may weld dyan, no? At saka meron tayong connection flange kahit isa lang yan, no? Yung sa example ko kasi doon sa classifications of structures, dalawa kasi na so although kahit at saka at least naka-weld naman, no. So ang meaning nito is a fixed supported connection or a moment connection, no. Uh, ito ang ginagamit mostly pag may lindol, no. So may stiffeners pa. So ang purpose ng stiffeners is for the hindi mag-buckle yung column natin. So itong column natin, not only carrying niya na load is the axial, no, it also carries bending loads, no. So obviously sa concrete, no, unlike sa example kanya sa roller, may siya, may roller siya, may ball siya, no. Ito naman is that the fixed support connection. So napansin nyo dito, para maging fix siya, yung reinforcing steel is hanggang doon talaga. Yan, hanggang. So anyway, hindi naman to talaga yung actual talaga na no. Marami namang diyan. Marami namang example, no, na actual details, no. So lastly, ito sa torsional spring, no. Ang constant dito is K is the infinite, no. Meaning, yung torsional spring dito is all of the torsion or all of the moment is present, no, is restrained, no. Ibig sabihin hindi siya pwedeng magalaw, hindi siya pwedeng so in short, ang torsional spring dito is not a torsional spring anymore. Kasi hindi siya pwedeng magalaw no. Kung magalaw mo siya, meron yung K is merong laman. If freely mo talaga na magalaw na walang moment, yung K is 0. But this one, infinite yung K, meaning hindi mo talaga siya pwede basta-basta magalaw. Like fixed talaga siya. Yun ang meaning fixed, no? So yung kanina, pinagkaiba nito is hindi natin consider moment, freely siya mag-pivot sa kanyang joint, no? Freely siya. So K equals to 0, walang resistance na torsion, no? Walang spring na maramdaman. So freely talaga siya. So K equals to 0. Dito naman is hindi mo talaga siya magalaw, no? Kasi yung K niya is unlimited, no? Infinity. So in short, hindi na siya torsion spring. Dito hindi rin siya torsion spring. But between them, sa gitna nila, yun yung actual talaga, no? Pag sa gitna nila, pwede mo siyang magalaw pero may resistance konti. So yun yung between sa kanilang mga yung K natin is between 0 and saka infinite. So if K is infinite, it is a fixed support. So I think let's proceed to an example, no? So example, no. This is just a review, guys, no. Wala namang talagang mahirap dito, wala namang bago dito, no. Hindi ko na gagawan to siya ng bagong lecture kasi natapos yun na to. So sa atin, no, although it is a frame, although it is a truss, although kahit ano pa yan siya na structure, no, alam nyo naman paano gumawa ng reaction, no. Hindi ko na yan ulitin kasi sa mechanics pa lang yan, no. Mechanics ng rigid or mechanics ng deformable, no. Sa mechanics talaga mismo ng materials or mechanics ng bodies, no. Natapos nyo na ito. So as you can see, meron tayong actual na example na although this is just an idealized rin, pero sabihin natin actual, no. So dito napansin nyo meron tayong beam or structure na lang sabihin natin, no, supported by a roller inclined at 3/4, no. So inclined siya sa 3 pataas, 4 na takbo, no. So yan ang tawag diyan, no. 4 runs, 3 rise, no? Ganon. So, inclined siya, meaning ang kanyang ano is dapat perpendicular ang kanyang reaction. So, ang reaction dito since roller siya is that single lang. That is perpendicular to the surface. And another, we have a pin, no? So we have it is restrained in any direction, no? So mostly ang direction naman ito is vertical at saka horizontal. So we have a load inclined at 60 degrees, 12 kips or kilopounds, and a vertical 6 kilopounds load, no? Ito yung location ng kanilang mga loads. So anong gagawin natin first step? Very first step, gagawin natin ang free body diagram. So this is the free body diagram. As you can see, kung ito yung plane surface, ibaliktad nyo lang. So anyway, alam nyo naman yan, no? So ang run naman dito 3, ang rise naman 4. So ibaliktad nyo lang. So we have the reaction at A and reaction at B, which is ano natin sila, pinaghiwalay natin sila in its rectangular components BX at saka BY. So this is the free body diagram. Ibig sabihin free body na, wala na yung structure, wala na yung mga supports. So anong pinakauna natin gawin? So pwede natin hanapin ang RA, ang BY, BX, no? Pero ang pinakamadali dyan, mag-summation tayo ng moment sa B, no? So pag-summation natin ng moment sa B, no? And by the way, before I go that, no, kunting review lang. Hindi ko naman kailangan talaga ituro sa inyo to, na is equilibrium of structures, no? Lagi yung tandaan sa structure natin, since na ayaw natin yung structure natin na tumakbo, lagi yan siya naka-equilibrium, meaning kung nag-apply kayo ng force dyan, no, na external force, no, yung structure natin remain pa rin siya, static pa rin siya, nasa static siya. So ang magkakaroon dyan, since it is static, ang velocity niya or speed niya 0. So wala tayong acceleration, no? So acceleration niya is still 0, no? So meaning wala talagang pagbabago pag nag-apply tayo ng loading, na external load. So first, no? Ano ba yung mga common na ano? So summation sa moment, summation sa translations equals to 0. So summation sa rotations equals to 0, summation sa translation equals to 0, meaning equilibrium yan. No, 0, ibig sabihin wala tayong force na ano, if may laman yung force natin is F equals to MA, no, yung A natin is merong number, so it is not in equilibrium. So yung F natin or yung moment natin is equals to 0, no, yung summation ng lahat-lahat ng static, no, ng ating structure. So very first natin is mag-summation tayo ng moment sa B equals to 0. So ang actual natin na ano class, no, sa structural theory or kahit sa natutunan nyo noon, ang ating convention or sign convention is always that the positive side or the positive in the moment or in a rotation is always counterclockwise para hindi tayo magulo. Ganun yung gagawin natin. Pag positive yan siya, counterclockwise. Pag negative, clockwise. So ito yung convention natin, no? Summation of moment along B. So nag-summation tayo dito, no, sa B. So ayan, ito, nag-summation tayo dito sa B ng moment, no. So ano mangyari diyan? Hindi ko na to explain. Alam niyo na to, no? So pag summation moment dito, meron tayong tatlo na moment. So may moment tayo dito sa RA, may moment tayo dito sa 12, may meron tayo sa 6. So yung RA, since na walang moment arm ang kanyang X na ano, X component, same with 12K, no? Walang moment sa kanya ang X component. So ang atin na lang na moment dito is ang mga vertical. So anong vertical ng ano, RA? So ang RA natin is vertical is 4 times 5 lang. 4 over 5 lang. So yung vertical component nitong RA is 4/5 ng RA, no? Since yung ikot niya pa ganun, kung dito tayo sabi maghawak, ang ikot niya pa ganun. So negative siya. So gaano kalayo? 10 plus 10, 20. So ito naman, ano ang kanyang vertical component? So pwede cosine 30 or sine 60 degrees. So since na 60 degrees naman ang given, no, sine 60 degrees equals to cosine 30 degrees, no? Lagi nyo naman yan alam. So yung vertical component niya is 12K times sine 60 degrees. So ilan yung kanyang moment arm? So from letter B, no, from point B to this one is 10 feet. So 10 feet. Then lastly, minus tayo kasi yung kung dito tayo hawak, ang ikot niya is clockwise pa rin, no? Clockwise. So pag clockwise, ano ganun ibig sabihin? Negative. Counterclockwise, positive. So itong 12K lang positive natin. So lahat ito sila, summation nila lahat equal sa 0. So ano yung hinaharap natin? So maharap natin yung reaction na sa A. So ganyan lang kasimple. So i-compute nyo yan, 4.62 kips. So next, ano hanapin natin? So hanapin natin ang by at saka bx. So first, by muna tayo. Simple lang, hindi na natin kailangan mag-moment dito or mag-summation sa moment, no, kahit saan. So simple lang, mag-summation naman tayo sa forces sa vertical, no. So vertical forces. So sign convention, obviously, upward arrow means positive, no. Ganun lang, i-add lang natin lahat, no? I-summation lang natin lahat ng mga vertical forces equals to 0. So lahat ng pataas, positive, lahat ng ano, negative, pababa. So ito, positive, 4/5, no? Same, pataas kasi siya, pataas. Minus 12, negative, kay pababa siya. Plus by, so pataas yung ating gi-assume, by pataas, no? So minus 6 kay pababa. So anyway, itong 4.62 sa RA na yan, ito yun, no? So wala tayong mga moment arm kasi forces lang. So by natin, since yan na, 12.7 kilopounds. Lastly, yung sa bx natin. So same, sign convention is to the right. So wala nang ano nito, 3/5 na naman kasi yun yung ano niya. Yun yung horizontal component or x component. So cosine na naman gamitin natin. So same, no? Papunta doon yung ano, papunta doon yung sa RA. So positive. Yung 12K papunta naman doon. From dito papunta doon. So negative. Tapos ang BX natin nag-assume tayo papunta doon. So anong sagot? So ganun. Tama. So yung assumption natin na BYBX tama ang ano kasi positive, no? So 3.23 papunta doon, keeps. So let's take another example, yung meron na namang fixed, no? So this is a fix, no? So simple naman ito, same. Gagawin natin free body diagram. Okay, then finish na siya, no? Free body diagram na siya. So we have the, no, tatlong restraint kasi fix siya. So we have a rotational, no, restraint sa rotation, restraint sa vertical, restraint sa horizontal. So ito hanapin natin. So very first, pinakamadali sa lahat, ano naman tayo, tawag doon, bx muna. So napansin nyo dito sa bx 0 talaga yan. So anyway, bakit 0 siya? Kasi wala naman siyang wala naman siya ibang kasama dito. Lahat naman is naka vertical or saka naka moment. So anyway, first muna natin yung moment. So summation tayo dito sa b sa moment. So pag summation tayo sa b sa moment, so, ito na yun siya, negative 400, no? Ito yung negative 400 kasi clockwise. Ito yung negative 400. So 15 times 6, ito yung uniformly distributed. So 15, lahat sila kunin mo sa 6, mag-act sa gitna since na it is a uniformly distributed, unlike kung varying siya, no? Tapos ano yan siya? So 8, 4 plus 4, tapos kalahati nitong 6. So 8 plus 6 over 2. So yun na. Plus 160 times 4. So 160 times 4. So positive. Positive yan sila lahat kasi pa-counterclockwise. Ito pa-counterclockwise. So nag-assume tayo itong MB is counterclockwise. So positive yung MB. So ang result natin yung MB is negative 1,230 kilonewtons. Meaning, mali yung assumption natin, no? Mali tayo nag-assume na counterclockwise yung moment sa B. So yung answer natin is 130 kilonewton pa rin pero pag ganun na ikot. So ganun na ikot niya. Clockwise siya. So same with the Y, no? Sa BY. So napakadali lang ng BY. Summation mo lang lahat. Negative 15 times 6. Sorry ha. Bakit 16 yan? So sorry. Mali na ako kagad. Okay, sorry na ko siguro yan. So negative 15 times 6 kasi pababa. Minus 160 plus BY, no? We have a 250, no? Yan na yun. So if you can compute that, 250 kilonewton yan. Saka like I said earlier, sorry, wala na. So yung BX natin, wala yung laman, no? Kahit mag-summation ka dyan, BX equals to 0 lang. Summation of forces along X, BX equals to 0. Wala naman ikaw makita. Wala ka makitang iba. So ganun lang, no? Anyway, example lang ito na makadali lang. But anyway, thank you very much, no, sa for viewing my my students, no. Then I think this is the wala na. So thank you. Good day again.